All right, welcome back. And today we are going to solve one of a fundamental question. And it's actually an easy question compared to other Leetcode question, but it's a good primer to using one of the data structure that I will show you later. It's one of the very most, well, honestly, I'll just tell you what it is. It's a hash map. And you are going to use hash maps a lot of the time. There are even memes on the internet about how if you don't know how to solve the problem, try using a hash map. So this question is a prime example on how you can use a hash map. But before we go into deep of how to use a hash map, let me just introduce you to this problem. So this problem is called toSum. Very simple. Given an array of integer, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Like for example, in this example, 2, 7, 11, 15, and the target is 9. So just by eyeballing it, I know that you have to add 7 and 2, and then that's the solution. So index 0 and 1. So that is why you return 0 and 1. Cool. Let's go to the iPad. Now, let's take a look at this situation with 2, 7, 11, 15. Now, how would we solve this? Always think about the brute force way. Obviously, the brute force way, it would be try every single combination possible. And then if you have a combination that is correct, as in if you add them together, it will add to the target, you return those indices, right? So how would that look like? It could look like maybe like for I in, the nums, for j in nums, but then starting from like I because you can't repeat the number. So basically, this is a classic double for loop. So what you're gonna do is like, imagine you have, this is your I, and then for the blue, I do this one, and then you're just gonna check these two, check these two, check these two, and then until you reach the point where you reach the target, where you sum, for example, well, this one's gonna be easy because the first two numbers will equal to 9, and then you're just gonna output 0, 1, because that's the 0th index, and this one's the 1 index, right? So let's think about that a little bit. How much time would that take? Let me think. So if there's one I, looping through the whole array, that takes O of n, and then each time you loop through all the array, you're gonna loop through another time through all the array because you have a double loop, a nested loop. So that's another O of n, right? So then combined together, it's gonna give you O of n squared. So this algorithm is O of n squared. This is actually the brute force algorithm. So this is actually not what you want. Now, what about the space complexity? We just looped through all of it and we didn't add any extra data structure. So the space would be O of 1 because we didn't do anything special. Now, let's introduce a hash map. Why are hash maps good? Hash maps are good because to put things in it, it takes O of 1, and to retrieve things in it, if given that you have the key, it takes O of 1 time. So looking up is very, very quick. So how would you use a hash map to solve this problem? Well, you could have a hash map so that you could remember all the numbers that you've seen. So it's either like a hash map or a hash set. Hash set means you only have the keys. Hash map means the keys map to a value. Here we actually just need a set, to be honest. Oh, actually, I am wrong. The reason why we need a hash map is because we don't want to return the two values. We want to return the indices. So what do we want in our hash map? So what we're gonna want is for the key to be the value of the array, and then value of the hash map would be indices. Kind of like the opposite of this array. So that means my hash map is gonna look a little bit like this. Okay, for now it's empty. I'll show you what my algorithm does. 7, 11, 15. Let's make the target 26 so that I could iterate a little bit more. So here's what my algorithm would do. First, I will look at the first number, okay? And then what I'm gonna do, oh, actually, you know what? Let's make a more simpler version. I'm going to loop through this whole array so that I could add all the numbers I've seen into the hash map. So I see number 2, I do 2, 0. 0 because that's the indices. That's the index. And then I go to 7, and then 7. So these are keys and these are value, right? And then 7 will be 1. And then I look at 11, 11 will be 2. I'll look at 15, 15 will be 3. Awesome. Now, what I'm gonna do is I'm going to loop through them another time. Now, when I loop on them another time, this time I'll do something a little bit different. When I look at 2, what I'm gonna do is I wanna see if there's a complement in my hash set. Like for example, complement means 26 because that's the target minus my own number, which is 2. This is equals to 24. Now I'm going to use that number and I'm going to look up to the table to see if there's any keys that are 24. And unfortunately, there isn't any key. All right, so that means that failed. Now I'm at 7. 7, so do the same thing, 26 minus 7 equals 21. Is 21 inside this table? Nope. All right, I'm going to skip. 11, I have 26 minus 11 equals 15. Is 15 in this hash table? Oh my god, it is. Because it is success. Let's do green for success. So I'm going to say, all right, so the value I get is 3. That means that's the index. So I get 3, and I know that this value, at the 0, 1, 2, at the 2 index. So then this is going to be my return value. So if you looked at this, how long did it take to process this? Well, first of all, there is create hash map. When I made the hash map, I had to loop through the array once. So that is O of n. And then when I looked at the complement, I did it again. So I do the loop, or like the array visit. That is also O of n. All right, so then O of n plus O of n equals O of 2n, which is similar to basically O of n. So that is the time complexity. What about the space? What about the space? Well, we have a hash map, and how big is this hash map? This hash map will be linearly proportional to how many elements I have in my array. And then in the array, we have n elements, so space would be O of n. So yeah, so technically this is better in terms of time, and I'm pretty sure usually that's what they're looking for. But the space is actually more. So here, if we look back into this one, the space was actually smaller, but the time suffers a lot, right? Now there's a small optimization that we can do where we can turn the 2 into 1. So that means we can just loop through the array once. I'm not sure if they'll ask you that, but usually they might, just to see if you understand how to use hash maps or if you know how to do some small optimization. So we could do this again, but we could do it differently. Let's take our example again, 15, and then target would be 26, and then we'll have a hash map. So here, instead of going through the array and initializing the hash map already, what we're going to do is we're going to build the hash map while we are building the set, right? So what we're going to do is this. We see number 2, okay, and then we're going to see if there's our complement. It equals 24. Is it in the hash map? No, it's not. So I'm just going to add 2 here, 2, 0. And then 7, same thing, 26 minus 7 equals 19. Oh, 15. Oh my god, it was 19. Okay, so I remember here I was wrong, but anyways. Oh no, here's right. So 19, and then is 19 inside here? No, it's not. So I'm gonna add 7, 1. Same thing with 20, and then now I'm at 11. 11 equals 15. Is 15 inside there? No, it's not. I'm gonna add 11, 2. And then once I get to 15, 26 minus 15 equals 11. Is 11 in here? Yes, it is. Success. I'm gonna use green. We see the 2, and we are at 3. So then we're gonna output 2, 3. Or like 3, 2. I think that doesn't matter. Let's see. Yeah, I'm pretty sure it doesn't matter. All right, cool. So that's pretty much it. So because of this, time is O of n. even though back then it was also O(n), but this time you only do it through one pass. Excellent. All right, so that's pretty much it for the iPad. Now let's code it up. Seems pretty simple. All right, now first, what do we need? We need a hash map. Let's call it dictionary. All right, and then what do? We iterate through the whole array, taking into account the index and the value. So for I, which is the index, num, which is the value, enumerate nums. All right, so, and then enumerate it makes it so that we have the 0 and 1s. It's so that it sends tuples. It's a Python thing, but anyways. So if target minus num is in the dictionary, like I did before, when I did 26 minus 2 or 26 minus 7, that's basically what I'm doing. I'm checking if the complement is in the dictionary. If it is, then we're just gonna return the target minus num, the index that we've already seen, and the index that we're at now. But then if not, if we don't see anything, then we're just gonna add the new number and its index. And then if it actually goes out of the loop, it should error because they say it should have exactly one solution. So blah, 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 it doesn't matter because it should never end up there. All right, let's run it. Okay, that works. And if we submit it, excellent. Right, so that's pretty much it. That's for 2 sums. It's a good primer to using hash maps. Very fundamental data structure. You should always try to use it if you're stuck on a problem. And yeah, thanks for watching. See you in the next question.